Now, in this video, we're going to answer the following question. Find the value or values of k for which the quadratic equation 2x squared plus kx plus 2 equal to 0 has one repeated real root. If you find this video useful, please consider leaving a like, a comment, and subscribing to our channel for more content like this. The roots of a quadratic equation are the values of the variable that make the equation equal to 0. In other words, they are the solutions to the equation. A quadratic equation can have two real roots, one repeated real root and no real roots. In this question, we're told this quadratic equation has one repeated real root, which means it has a discriminant equal to 0. The discriminant is a specific value calculated from the coefficients of a quadratic equation that provides crucial information about the nature of its roots. For a quadratic equation in the standard form ax squared plus bx plus c equal to 0, the discriminant is given by b squared minus 4ac. So we need to do two things. First, we need to find the coefficients a, b, and c for this quadratic, and then we need to use the discriminant to find values of k that satisfy the condition that the quadratic equation has one repeated real root. So, let's begin by writing the equation. 2x squared plus kx plus 2 equal to 0. Then the standard equation of a quadratic, ax squared plus bx plus c equal to 0. And we can see that a is equal to 2, b is equal to k, and c is equal to 2. Now let's write the discriminant b squared minus 4ac and make it equal to 0 for one repeated real root. Substituting our values of a, b, and c gives us k squared minus 4 multiplied by 2 multiplied by 2 equal to 0, which we can simplify to k squared minus 16 equal to 0 and k squared equal to 16. Therefore, k is equal to the square root of 16, which is equal to plus or minus 4. So values of k and the answer to this question are equal to plus or minus 4. If you found this video useful, please consider leaving a like, a comment, and subscribing to our channel. Thank you.